One quantity that's important for us to know in a lot of contexts is mass. So how do we find the mass when we're dealing with an ionic compound? Well, simply, it's because mass tells us how much stuff is present. It tells us how much matter we're dealing with. When we're dealing with a compound, whether it's ionic or otherwise, one of the most important things about compounds is that it's not just some random collection of things. Compound has different elements present in a fixed whole number ratio. So in order to use that fixed whole number ratio, that's the balanced chemical formula that we're talking about. We need to figure that out, and then we can figure out a mass of that formula that'll help us quantify how much material we've got. Now, big picture, this isn't really that hard. It's pretty simple. If we want to know the mass of the formula of the whole thing, we just need to add up the pieces. So that's pretty simple, but in order to add up the pieces correctly, we need to have the correctly balanced chemical formula. So the difficult part of formula masses isn't really the mass, it's writing the chemical formula that we need to start the problem. So let's look at an example. Let's just look at sodium chloride, right? Sodium chloride is one of the chemical formulas that everybody probably knows, right? It's NaCl. So what's the formula mass of sodium chloride? Step one, write a correctly balanced chemical formula. NaCl, we know that one. Step two, add up the masses, the atomic masses from the periodic table. So if we look at the periodic table, I just pulled out sodium and chlorine. The atomic mass of sodium is 22.990 AMU. The atomic mass of chlorine is 35.453 AMU. If I've got one sodium and one chlorine, add them together, 58.443 AMU. There we go. That's a formula mass. That didn't seem so tough, but I kind of cheated and I used sodium chloride. It's about the simplest ionic compound you can use. So let's try a little bit more complicated formula, but the same process. What is formula mass for calcium phosphate? So step one, write that balanced chemical formula. If you find calcium, calcium is atomic number 20. It's in group 2 of the periodic table, and since it's in group 2, we expect that it's going to have a charge of +2. Phosphate is one of those polyatomic ions, so hopefully you're making some progress in memorizing those, but phosphate is PO4 -3. So if we want to balance this, we've got the positive charges coming in +2 at a time. We've got the negative charges coming in -3 at a time. So to get those to balance and cancel each other out, we need what? It sounds like we need 3 plus 2's and 2 plus 3. So we need 3 calcium ions to get us a total of +6 charge, and 2 phosphate ions to give us a total of -6. So +6 -6, those cancel out. So the formula is calcium Ca2 PO4 2, Ca3 PO4 2. And here, when we're using polyatomic ions and we've got multiples of a polyatomic ion, make sure we're putting those in parentheses. So this 2 means that we've got 2 of this entire polyatomic ion. Step 2, add up the atomic masses from the periodic table. What do we have? We've got 3 calciums, so 3 times 40.078, that's the number of the periodic table, plus 2 phosphoruses. Remember, this 2 applies to this whole unit, so we've got 2 phosphoruses at 30.974 AMU, and we've got 8 oxygens. Each phosphate is 4 oxygens. We've got 2 phosphates, so it's a total of 8 oxygens at 15.999 AMU. Add them up, 310.174 AMU. So these can get a little complicated as far as just how many terms we've got, but really the key is write that balanced chemical formula and then just count the pieces that we've got present in that formula. There are a few little twists and turns we can take. One specific one that comes up fairly often is the case of hydrated ionic compounds. Sometimes when an ionic compound crystallizes, it crystallizes with water molecules chemically bound to the cation or the anion or both. So we call those hydrated ionic compounds. They're not just like damp, wet to the touch. They actually have chemically bound water molecules, a specific number of chemically bound water molecules in the chemical formula. So that's not any more difficult than the other ones. The step that trips us up is, again, just writing that balanced chemical formula. So what is the formula mass for a hydrated ionic compound, copper 2 sulfate pentahydrate? So write a balanced chemical formula. Copper 2, copper is one of those that can have multiple charges. Our Roman numeral 2 here designates that this has a charge of +2. Sulfate, another one of those polyatomic ions, SO4 -2, so +2 -2, that's pretty good. And pentahydrate, penta 5, hydrate waters, so 5 waters in my chemical formula. And water is a neutral molecule, so it doesn't matter how many there are, it doesn't affect the charge balance, but the number is a very specific number when we're working with that. So copper sulfate, +2 -2, pentahydrate, 5 waters. Step 2, add up the atomic masses from the periodic table. We've got, what do we have? We've got 1 copper at 63.546 AMU. We've got 1 sulfur at 32.066 AMU. And now, well, let's make sure we do our counting correctly. We've got 4 oxygens on the sulfate, but then we've got 5 water molecules, so that's 5 additional oxygens. So we've got a total of 4 plus 5, 9 oxygens, each at 15.999 AMU. And we've got 5 water molecules. They each have 2 hydrogens, so there's a total of 5 times 2, 10 hydrogens at an atomic mass of 1.008 AMU. Add them up, we get 249.683 AMU for the formula mass of copper sulfate pentahydrate. Again, it's not really anything different. The key is just writing this balanced chemical formula with all of the important parts, in this case water molecules, and adding up all the pieces that are present there. So formula masses, again, it's something that just takes a little bit of practice, and the biggest part of the practice is writing the balanced chemical formula. So look for opportunities to practice this, and practice anytime you have a chance, and you'll get much better at it much quicker. See you next time.